right? And you can get a table of values from your calculator. It's just a parabola. It's a graph we've talked about tons of times throughout the semester. It's not anything fancy. But when I graph the inverse, I'm going to take the values that I have here, and I'm going to flip-flop them. Okay, like for instance, 0, -5 would be an ordered pair on the original. So then -5, 0 would be the graph on the new one. And you want to do several points, okay? It's a parabola, so you want some points on either side. You want to see where the parabola is going to be. And one thing that you can always remember is that this line, the y equals x line, is going to be the reflection line. So when you reflect those points, you should be reflecting over that line. And that kind of gives you a visual of, does it look right when I put my new points down? Okay. So, like for instance here, 0, -5 would be down here. -5, 0 would be over here. Those are 2 points that are reflected. You want a few other points, obviously, but that's the way I would approach that problem. Okay. On number 2, f of x is really the same as y. So it's really y equals the cube root of x minus 7. So when we do the inverse, we're going to flip the x and the y again. And when we solve this one, because we're trying to write the inverse of the function, then we're going to have to solve it for y. So what you have to really pay attention to here is, where is the -7 at? Okay? In this case, the -7 is under the radical. So what could I add 7 as my first step? No. If the -7 was outside the radical, then I would add 7 first. But here, I got to get rid of the radical or the cube root first. So we're going to cube both sides. And then we would add 7 to both sides. Okay. So really be careful of the order that you would solve it in and in what direction you would go. Okay, number 3 is a little bit tricky. Because of this extra piece of information right here, x is greater than or equal to 0. If I graph x squared minus 7, it's going to look something kind of like that. Okay, you can put it into the calculator and get your graph. This is kind of like number 1, except that we're talking about domain and range. We're not graphing it. Typically, if I have a parabola, what would I say that my domain is going to be? All real numbers, right? It's going to continue in both directions, all the way. Okay, but because we have this restriction, x has to be greater than or equal to 0. So instead of saying all real numbers, we would instead say 0 to infinity. So they kind of throw a little bit extra restriction in there. If I didn't have that restriction, it would be all real numbers. But x greater than or equal to 0 means it can only be 0 to infinity. My range here, because this goes down to -7, would be -7 up to infinity. And then it wants to know what is the domain and range of the inverse. So the range becomes the domain, and the domain becomes your range. Okay. So you just flip-flop. So in my answer key, when I post my answer key, the real answer here would be C, okay? If I didn't have this little restriction in here, my answer would be A. So that restriction throws it off. And so I had a lot of people saying A the other day, and so that's why I added that to my answer key. If that wasn't there, then it would be A. Yeah, Armani?
When finding the inverse of the actual function and graphing that, can you okay to do?
Yeah, you could do that. Yep, that should work as well. Sometimes that's not always, you may not be able to graph some of those though. So that's why, that would be the limitation there, is that sometimes it wouldn't be something easily graphed in your calculator. Okay, number 4 is just a graphing calculator question. Just put that into your calculator, evaluate it. Should be pretty simple. Number 5, put it in, come up with a couple of values. Just really be careful of like your asymptotes on questions like that. Where is it approaching? Make sure it doesn't cross that line. In this case, it's the x-axis, so make sure your graph doesn't cross the x-axis. So those would be big things that we're looking for. On this one, obviously, there's not really anything that you need to put on the blank. You're just graphing it, okay? 6, we had one like this on the quiz. When it says to describe the position, really what we're talking about is we're talking about how does it change, how does it move, how does it shift, right? So this is my original function. The only one it really wants us to graph is this one, okay? This is my original. If you want to graph them both, go for it. The only one that you have to graph is this one right here. But we're talking about the change that we have to do from here to here. So how does the graph shift or change? Well, the number that is attached to the x, up here in the exponent, is going to move it which direction? If it's x minus 3 in the exponent. Right, 3. And then the minus 3 at the end tells me it's going to go down 3. Okay, so somewhere you could write it on the blank over here, you could write it here, I don't really care, but you need to tell me that's what it means when it says describe its position. Just tell me how it's changing. And then the big thing here is that this is now going to be my asymptote. My original function, 4 to the x, is a growth function, and we're taking that whole thing and shifting it right 3 down 3. Okay. For me, I like to graph both just to see that it's moved right 3 down 3. So a lot of times I'll graph both of them, but you really only need to graph the x minus 3, minus 3. 7 and 8 are the two that have your formula. They're on your formula sheet. Make sure you know what all the different types of compounds are. There's quarterly, semi-annually, monthly would be 12 times a year. When we say compounded, it means how many times a year is it happening. So semi-annually would be twice a year, every 6 months. Semi means half, so half a year it gets compounded. Okay. If it says continuously, then that's where you're going to use the per formula. Make sure you know how to put those into your calculator, because those are really just calculator problems, because you've got the formula given to you. Yeah? No, you'd put 2, because it means how many times has it been compounded. So your n will always be a whole number. So if it's semi-annually, you'll put 2. If it's quarterly, you'll put 4. Monthly, you would put 12. So it's always an integer. But make sure that you change your decimal, or change your percentage to a decimal. So when it says 10%, make sure you put it in as 0.10 when you put it in your rate. And here, 0.01 would be your interest rate. I had a lot of people ask me about number 9 on Friday. If you haven't done this one yet, then we're wanting to know, when are these two countries going to have the same population? And we're going to estimate the year when it happens. So X is how many years have passed since we began. Y would be the population. So there's all kinds of different questions that could be asked here. I could ask you how many years have passed. I could ask you in what year would we be looking at? Or I could say, what's the population when the two countries are the same? So these are two made-up countries, East Goma and West Goma, and they give you a function that represents the population of those two countries. Okay, what you will probably have to do here is either zoom out or change your window, okay? Because you want to find the intersection of these two, and in order to do that, it's a little bit outside the standard window. And so you'll have to change your window somehow to be able to see where they cross. And then you can just use your intersect feature on your calculator. When it gives you an ordered pair, X and Y here, X is the number of years that have passed. Y is the population at that point in time. So be careful with the question that's being asked. In this case, estimate the year. So whatever I get for X, I have to add that back to my original year, which is 1998 when we started. Okay. So if I said 3 years have passed, then I would add 1998 plus 3, and it would be in 2001. They would be the same. Okay. If it was like 3.5, then I would add 3 plus another half would put me into 2002. Okay, so if you're like 3.5, you're into that next year, so you would be into 2002. So this one wants to know what year will they have the same population. You don't have to get real specific, like what month or anything like that, just what year. Okay, on number 10, there's a couple of different ways that you could do this one. You could do this one, maybe the easier way to do this, because the way I showed you on the quiz was to rewrite it like this, to write it in exponential form, and then kind of do it backwards. Instead of plugging in for X, plug in for Y and find out what X is. This was missed quite a bit, so I think some people really struggled with that. If you have the log base button in your calculator, then it makes this a little bit easier. But just know that these two are the same. If it's given to us like this, another thing you could do here, if you don't have that log base button, and I saw a few people do this, they use their change of base rule, and they put it into their y equals like that. So if you wanted to do that, that would be fine. This is the opposite of an exponential growth function or a decay function. If it's an exponential function, it's approaching the x-axis. This one is going to approach the y-axis. And what happened on this one? Okay, 11, just evaluate it. 12 is one of those where you're going to convert it to a log equation. Some of them have log in them. Some of them have ln. If you have a base e, typically we would use ln. But I could rewrite this one like this. There wouldn't be anything wrong with this if I used log, but I would have to put base e down there. If I put ln, I don't have to put base e because it's assumed to be base e. So either one of those would be acceptable answers, but because it's multiple choice, then we would go with the one that is listed there, which is C. Or sorry, E. Oh, I wrote it out wrong, didn't I? That's my fault. So it should be B, yes. E to the negative t. That's my fault. I wrote the first one right, but not the second one. Okay. 13, you're going from exponential, or a log to exponential. 14 is just your change of base formula. If you have the log base button in your calculator, then that's a little bit easier. If you don't, then you would put it in like this. Make sure you close off the parenthesis. We had some like that on our quiz, so we've done that several times. Okay, number 5. This is one of those transformation questions. This is my original function. This is my new function. So once again, when it says describe the position, what we're going to do is we're going to describe what changes, right? What is different, what is happening. And so in this case, this would probably make more sense to us if I wrote this function like this. If I see the 5 at the end, it probably means a little bit more to us, right? If the number is connected to the x, it'll be in parentheses. So if it was like x minus 3, then that means it's connected. This is not connected to the x, it's after the function. Okay, so here's my function, we have a plus 5 afterwards. So what's going to happen to this graph? What direction is it going to?
Left 5.
Okay, if I had this, it would be left 5, okay? But on this one, because there's no parentheses, the 5 is at the end, so this one would actually go up 5, okay? So if there's no parentheses there, it means it's not attached or connected to the x. So it's a little bit tricky, and I think that's why they put the 5 in front. They want you to know that it's not connected to the x. I know this is the way that we're more used to seeing it, so that's why I rewrote it like that. But just know where that 5 should go. We had one like number 16 on the quiz where you're just solving it. They tell you what the value of t is. You're going to plug it in and solve it. Okay, here is where you have to do your log rules. You have to know your log rules here. These are not on your formula sheet, so these are ones that you should know. The ones that you should know the most are the product rule, the quotient rule, and the power rule. Okay, if there's nothing between the x and y, what are we assuming is happening between the x and the y? Multiplication, right? We're taking x times y right here. So that is a product, right? And when we separate them, because it says express it as a sum, so right there, that's the key, right? It's a sum. We're going to have the log of x base 2 plus the log of y base 2. Okay, immediately, I probably could eliminate b and c because those are not sums, those are difference. And that is not what's happening here. 18 is division, so that's the quotient rule. When I separate them, it says express as a difference. So just look for your key word there. And the key word should really help you with writing those out. This one has multiple things in it. It actually has the product rule, the quotient rule, and the power rule all in one. So you're going to separate it out, writing it as sums and differences. You're going the opposite direction. They give you the long expression already written out. We're going to combine it into a single log. So we don't want multiple logs in our answer. We want just a single log. So you're still applying the rules, just applying them in a little bit different way. Going the other direction with it. 21, I had a lot of questions about this one on Friday as well. Basically, it's the same directions where if I have multiple logs, I want to simplify this as much as I possibly can, okay? So we're going to go from multiple logs into a single log. Because I have a minus sign in between my two logs, how am I going to write those two expressions? What am I going to do with them? Even before we factor though. Divide, right? Because we have a minus sign. Minus this sign right here tells me we're going to divide those two. So that number or that sign right there is the big thing. All right. What a lot of people want to do is they want to do the log of the top and the log of the bottom. This is just now a single log. So we only have one log in our new expression, and we divide the two expressions that we were taking the log of. The first one goes on top, the second one goes on bottom, okay? I can simplify this a little bit more because I can factor the top and the bottom. So if we can simplify it more, we're going to simplify it more. This one up here would be product and sum, and what multiplies to get 2 and adds to get -3. Would be -2, -1. And then on bottom we have DOPS. So that would be y plus 1, y minus 1. And then what you'll notice is those y minus 1s can disappear. So we're left with would it be okay for me to knock these y's off? No, because these are connected with two different things. This one's connected with -2, this one's connected with +1. So in order to knock this out, I would have to have a y minus 2 on bottom. And I don't have anything down there I can knock it out. So do not knock those y's out. The only time you could do that is if you have multiplication there. Okay, we did a couple of these together, but 2 and 5 are the two separate expressions that I have, and somehow 2 and 5 together have to make 10. What would I do with 2 and 5 to get 10? Multiply it, okay? So I'm going to rewrite this. Those two things are the same thing, right? I can rewrite 10 as 2 times 5. Because we have two separate things here, I could separate them now and use my log rule. Because I have a multiplication sign in between the 2 and the 5, I could rewrite this as log 2 base A plus log 5 base A. Hey, the reason we want to do that is because I can't just plug this into my calculator to get log 10 base A. We don't know what the value of A is, and they're not going to tell us what the value of A is. We don't have to find A. We have to use these two things to find this. So that's why we have to figure out what do I have to do to 2 and 5 to get 10, okay? And it's going to be some combination of multiplication or division or something because that's using our rules. It could be a power rule, maybe, but those would be the three rules that we're going to use somehow. Product rule, quotient rule, or power rule. Somehow using 2 and 5 to get 10. Okay. And now we know log 2 base A is this. We know log 5 base A is this. So all I got to do is add those together to get that. Okay. And so it's just adding them up. But you have to know how to separate them first. All right, on 23, I helped several people with this one on Friday. There's a lot of different ways that you could approach this. When you solve these exponential rules or equations, there's not just like, sometimes this is the only way to do it, but there are times where there's more than one way to get there, okay? One of the things that I showed some people was, this would kind of be an easy way to do this. If 3 to some power is 81, then that would make this problem a whole lot easier. Okay? And I'm not expecting you to know if it is or not, necessarily off the top of your head. Okay? But if it is a nice integer power, then that makes this a whole lot easier, right? So can I raise 3 to some power to get to 81? Yeah, right? It would be what? 4. So 3 to the 4th is 81. And so what they're saying is 3 raised to the 12 minus 2x equals 3 to the 4th. Because 81 is really 3 to the 4th. Okay, the reason why this makes this a whole lot easier is because as long as these two are the same bases, which they are, then what would I do with my two exponents? Just set them equal, okay? So all I would have to do is say 12 minus 2x equals 4, and now it's just a easy two-step equation to solve for x, okay? So for me, that would be one quick and easy approach that you could do. But it only works if 3 raised to the power is 81, okay? The other thing that you could do here is you could log it, frog, and solve it. I could log both sides, I could jump this whole exponent over the log, and then I could divide and then solve. But that's a little bit more work, okay? So could you still log a frog and solve it? You bet. But that would be kind of the longer method to solve it. So just trying to show you that you can do it a couple different ways. 24, graph it in your calculator. This is one of those. Set it equal to 0 first. So I'm going to subtract 1 from both sides. Set it equal to 0. Put it into your calculator and find out where does it cross the x-axis. Okay? And that's your solution. That would be the quickest and easiest way to do that. 25, I did put the log, the loop or the circle rule on there. The log loop or the circle rule, same thing. So if you change this to a exponential equation, then I could just do that. And now it's a piece of cake, right? I can just put 25 to the 1/2. Taking 25 to the 1/2 is really the same thing as doing what? Taking the square root of it. So 25 to the 1/2 is the same as taking the square root of 25. So it would just be 5. Okay, 26. Here's another one where you're using your log rules. So there's quite a few of them where you're using those log rules, so you really got to know those. We got a minus sign in between, so that tells me this is quotient rule. Set up your equation, and then you're going to have to solve for x. Okay, these last 3 problems is where you're using that last formula that's on your formula sheet. This was from the last section that we did, where we did exponential growth and decay of some type of story problem or some situation. It could be population of a city, or it could be a species, or it could still be money. It could be a lot of different things. Okay, but it's some type of story problem. So all 3 of these problems are dealing with doing problems like that. This one is just rewriting it as an equation. Okay, and so a couple of things. If I gave you a 1% growth, kind of like we talked about earlier, what do I have to do with 1%? Change it to a decimal, okay? So immediately, I could eliminate D, because it didn't change the 1 to 0.01. So D is out, right? The formula that's on your sheet is P sub 0 times E raised to the K times T. P sub 0 is what our starting amount is. So this country started with a population of 38 million. So 38, they didn't write out the entire 38 million. They just said 38, which would represent 38 million. So then if you were to do an answer, you just have to know your answer is going to be in millions. All of those have 38 so there's nothing difference between A, B, and C there. And then B is missing the E, right? B doesn't have the E in it, so B is out. And then A is missing the T. So they're missing different parts of the formula. So just kind of by process of elimination, that one shouldn't be too bad. You're not really doing anything with the formula, you're just identifying which one is the correct formula. Hey, we did some problems like this, and I showed you a shortcut that you could do. You can do this shortcut anytime you have double is the one that happens the most, but if it was triple, I would do 3. If it was half-life, I would do a half. But doubling is the one that we see the most. there's two ways that you can do this. I can take ln of 2. 2 is because it's doubling, divided by k equals t. Or I could divide by t to get k. So if I know how many years I want it to double, I could find out what the rate would be. And that's what I would use here. If I knew if it said 7 years, I would take the ln of 2 divided by 7. If I said the rate was 7%, then I would take the ln of 2. But once again, it's a k value. So because it's 7%, what do I got to make sure to put into my calculator? Anytime we're dealing with a rate like that. Decimal. It's got to be 0.07. Okay. So you could go through the whole formula if you want to, but that is the quick shortcut that we can use. Okay, and then on this last one, you just got to make sure you read it carefully. There are currently 77 million cars. It's decreasing exponentially by 5.5%. How many years will it take for this country to have 67 million cars? Okay, so when we put this one in, the number that goes right here is my starting amount. Right now, it is what we have, 77 million. We know the rate. The rate is 5.5%. So that's going to be 0.055. We do not know t. We want it to end up at 67. Okay, and probably what we want to put, we probably should put a negative 0.055 in here because it's decreasing exponentially. So we want to make that k value negative. If it was increasing, it would be positive. So that way we don't get a negative on our answer. If you don't put a negative on the 0.055, you would get a negative number of years, which wouldn't make sense. So that would be the big difference. So to solve this one now, you would first, what would I do first to start this? I'm going to let you solve this one out. I'm just helping you get it set up. But what would I do first? Divide by 77. Okay? And then log it, frog it, solve it. Okay? And get t by itself. And t should be how many years it would take. And we're just rounding to the nearest year, it says. So round to the nearest whole number. Okay.